All right. Hey guys, Mr. Milton here. Today we are going to look at points, lines, and planes for our first lesson of the year. At the end of this lesson, you should be able to name, define a point, a line, and a plane using standard geometric representations. And you should also be able to identify and name intersections of specific points, lines, and planes. All right, so before we start, we need to make sure that we understand a couple things. A definition is not necessarily what we had been thinking of it before. Make sure I'm doing this right. All right. A definition is not what you understood it to mean in everyday life. It's a little bit different in math class. For mathematicians and for us this year, a good definition has a few characteristics. Okay, so one of them is that it uses clearly understood terms. Okay, the words should be commonly understood, are already defined. It's objective, okay, and that means that we're not really worried about other people's opinions about what a word means, like small or large or weird or sort of or some, like those kind of words. It should be defined and it should be objective, okay? And also, it's not disproved, okay? And so what that means is if somebody does disprove it, then it can no longer be a definition, okay? And so kind of a more difficult thing to do here at this point, at least in our lives, mathematical lives, I'm asking you to define a couple things. So here it says define a truck, okay? This is just an example of how we might think of definitions is a little bit different than what is acceptable in math. Because if I ask you what a truck is, you know what a truck is. Okay? And somebody might say, well, it has four wheels and it drives. Okay, so I'll say, I mean, in the math world, people would be like, well, so is a sedan a truck? Is a sports car a truck? You say, well, no, a sports car is not a truck because a truck has an open bed. And so then you could say, well, is a semi-truck a truck then? Because it has a closed bed. So you understand that what we're trying to do is give a definition that's going to be universal. You can't disprove it, and it's also going to relate to the situation. Okay, you can do the same thing with a dog. You might say something that barks, and somebody says, well, it's a seal. Okay, and then you say, well, four legs that barks, and then, I don't know, I had a three-legged dog in my neighborhood. So is that still a dog? Yeah. So definitions in math will have a little bit more, especially in this course, will have a little bit more to it than just a common understanding or a general understanding. Okay, with that said, in geometry, we will have a few undefined terms, okay? And when we say undefined, we don't mean that there's not a definition. We mean that there's basically, we need further understanding in order to define, okay? And so, therefore, the following are not definitions, but rather general understandings, okay, of their meanings. Okay. So, here are the terms. First, a point is a location with a location in space. It has no size. Okay. It is represented by a small dot and named by using one capital letter. You might say uppercase, I say capital. Okay. A line is a series of points extending in two opposite directions without end. It's named by any 2 points that are on the line, or a single lowercase letter. Okay, and it's usually italicized. So here, just to name the line, it says name the line in 4 different ways. And here's how we can name this line. First of all, it's very important that we mark that it's a line. When we do that, we'll have this symbol over top with the arrows going both ways, show that it's a line and not a line segment or array. So we can name this line PT. We could also name this line PW. We could name this line TW, or we could name this line M. And I'm going to make sure that my audio is working. If it is, okay, great. All right, so those are the 4 ways that we can name that line. Now, I want you to notice that reversing the order was not a new way to name the line. So I called line PT. I wouldn't say, well, line TP is another way to name it. Okay, because it's basically the same thing. You're using those 2 points. Okay. So in the above example, we say that points P, T, and W are all collinear. Okay, and what that means is that they share a line. This prefix co will be important. Co means together. So if you say cohabitate, you live together. Collaborate, you work together. Commiserate, you complain together. Okay, so co means together. Okay, going down to using some of these terms in our examples. So it says R, E, F, and C collinear. As we look at this, I'm trying to move my dot. Okay, we see E here. We see F here. We see C here. Notice that E and C are kind of made by where the location where our 2 lines meet. Okay, so are E, F, and C collinear? Take a second, answer this. Answer the 2 questions. So as you look at it, yeah. Yes, they are. They are collinear. Okay, what line do they lie on? Well, they lie on line M. Okay, so they lie on line M. Yes, they are collinear. Are C, D, and P collinear? So as we look at this, I'm going to erase these things. Get back to a different one. All right, so C, D, and P, as we look at C, still here. D, here, P. Okay, get to my ruler. So when we look at these points, there's no way for us to make a line that goes through all 3 points. Okay, so they are not collinear. It would be collinear if there's a way for me to make a line that goes through all those 3 points, and there's not. So the answer there is no. And since the answer is no, there's no answer there. And then finally, are P and C collinear? So take a second, answer that question. So P and C, even though we look at P and we look at C and there's no line that goes through PC, our ruler shows that, hey, there is a line that will go through PC. Even though it's not drawn, it's here. There is a line that goes through PC. So therefore, P and C are collinear. The answer is yes. P and C are, oops, still have it on erase. So the answer is yes, P and C are collinear. Okay. Question 3 above is actually our first postulate. And a postulate or axiom, we'll use postulate more, is an accepted statement of fact. Okay. And what this fact is, this postulate or axiom is that through any 2 points, there's exactly 1 line. Okay, and we see that even though there was not a line drawn through PC, there is a line that can be made through PC. And we can say that about any 2 points on the line, whether it's FD, FP, you can make a line that goes through. Okay. The second postulate says if 2 lines intersect, they intersect in exactly 1 point. And we also made use of that as we looked at the locations between where line N and M met. We saw point C, right? Okay, so we talked about points, we talked about lines, and now our third undefined term is plane. Okay, and a plane is a 2-dimensional surface with no thickness. Okay, 2-dimensional, it goes left and right, it goes up and down, but it doesn't get any thicker. Okay, so basically we will represent this a lot like a piece of paper, kind of. Okay, like imagine a piece of paper that goes on forever and ever and ever. Okay, with no thickness. It is named by at least 3 non-collinear points. Okay, and collinear. That's the most typical way to do it. Okay, that's how we'll usually do it. Or it can be a single capital letter. So as we look at this plane over here, we could call this plane ADB. Can I find it? Erase this. Okay. ADB. We can call it plane DBC. Or we could call it plane ADC. Let's call it that. Okay, again, just flipping the order around does not make a new way to name it, but it is important to note that when we named it, we did not use ABC as a way to name the plane, and here's why. Okay, so say you have a line, right? ADB. Let's say ADB. We have a line, and then we have a plane that we're using. We'll just say this: it's a piece of paper, right? As we use this piece of paper and we say, hey, this is the plane ADB, or sorry, ABC, because it all lies on this plane. Well, if we changed our plane, remember our plane goes two-dimensional, so it goes this way and this way and this way and this way. We can imagine a plane, or there is a plane that still would be collinear, well, would contain this line, but would not be the same plane, okay? And so each plane, each time I rotate this plane, it changes the plane that we're naming. And so naming collinear points does not define how the plane looks or where the plane is located. It only does that with 3 non-collinear points, because basically you'll have 2 that's a line and like 1 that's a stopping point. Okay, and I can go through that more if you have questions in that in 3 dimensions. Okay, so we say that the line and point D, so you'll see ABC, the line AC, and point D are coplanar, and that just means they're together on a plane. Using that prefix again. Okay, the third postulate says that if 2 planes intersect, then they intersect in exactly 1 line. Okay, and so you'll notice this in the room that you're in right now, that where 2 planes meet, whether it's the floor and the front wall, there's a crease, that line. Okay, so when 2 planes meet, they make a line. Okay, and the final postulate says that the final postulate for today says that through any 3 non-collinear points, there's exactly 1 plane. So through any 2 points, there's a line. Through any 3 points, 3 non-collinear points, very important that we add non-collinear points to that, okay? That there's exactly 1. I wrote 1, 1 again, but I said plane out loud, okay? Plane. Okay. So we're going to go through some of these examples. I'll give you a few seconds to answer the questions as we do it. Use your OneNote, use your paper pen highlighters to answer these questions as they come up. Will be helpful, I think. And so the first one says, name the plane representing the top of the box. So I'm going to look at the top of the box here, the points that are here, the top E, G, F, H. These are on the top of the box. So if I'm naming the plane here, then what I want to do is I want to use 3 non-collinear points to do that. And it's not going to be hard to be non-collinear because I don't think there are more than 2 that would be considered collinear. So we will name this plane EGH, for example. And that works out. You could have also named it EFH or FGH. Okay. Number 2 says, what is the intersection of GH and CG? So try that out. So GH, this line that goes through here, continues on. CG, this line that goes through here continues on. Okay, and you should see that, hey, they do meet at a point, and that point, that location is G. Okay. Number 3, what is the fourth point of BFH? BFH. Okay, so as I look at BFH, I'm naming BFH, saying how can I finish this piece of paper? This front plane. So BFH also includes point A. What is the intersection of EDA and CAB? So EDA, as I look at it, should be that left side, right? EDA, finishing off the point and say, or the piece of paper say that F is included. And CAB, so look, CAB, okay, finishing off that piece of paper and saying that DA is included. And then as I look at this, I'm like, okay, what's green and blue? DA, that's the intersection. So line DA, I'm going to make sure that I include in my notation that it is a line. AD, DA works out the same. Number 5, what is the intersection of EG and CDG? So as I look, EG, erase it so I can see. So EG is back here, and CDG is 3, so I know it's naming a whole plane, it's naming this whole side, not just these 3 letters, right? If they're saying CDG, naming a whole plane. And so then I say, okay, what's red and blue? EG, line EG is what it's naming. Okay. Then I'll go from here. What is the intersection of GH and FAB? What is the intersection of GH, which is here, and FAB? So FAB seems to be the front. Oops, I should use a different color. FAB is the front. Okay, and so you'll see, like, okay, it's not like number 5 where it was that whole line. These meet at just one point, and that point is H. Oops. And that point is H. Okay, and then finally, what is the fourth point of EDB? So the fourth point of EDB, okay, the fourth point of EDB here, ooh, no, okay, EDB, ED, it's kind of weird because B's all the way over here, so it's not like the other problems where we're like, oh yeah, it's the wall, it's the ceiling, it's the floor. This is a different plane, okay, but my understanding of planes up to this point, at least, is that I'm trying to complete a piece of paper. I'm trying to make a piece of paper. Let me do this better. Okay. So as I go from here to here, trying to be a straight line, okay, there's a piece of paper that goes across this room basically diagonally. So the fourth point will continue that diagonal piece of paper, and that is from E. Man, I'll get better at drawing on this thing, but it wasn't too bad for this one. All right, so this diagonal piece of paper here cuts the room in half, that diagonal, that plane, and that other point is point H.